If you have an electrical load that's quite a ways away from your fuse block and you want to be able to control it with a switch from a long way away, you're going to need a relay. And that's exactly what we're going to cover today in lesson number 6 of this branch circuit playlist. My name is Nate and welcome to the explorist.life Mobile, Marine, and Off-Grid Electrical Academy. Now before we get started, there's a couple prerequisite pieces of information you need to know, like cutting wire, stripping wire, crimping terminals into wire, but we've already covered that in a specific playlist of this academy, so go back and review that if you don't already know how to do this part. And lastly, before we get started, the fuse block that we're using in this particular demo is the Blue Sea blade fuse block. Now, there's several different types of fuse blocks on the market, like the Progressive Dynamics fuse block, the Blue Sea Safety Hub, the Tiger Expedition UFO 200, and all of those are realistically going to be connected in much the same way. They're all getting their power from a different distribution hub, like the Victron Lynx distributor, which is getting its power from the battery, but we're going to skip all of that side of the system and focus mainly on how we get power to the rest of the branch circuit. Let's get started. I already have all this pre-wired up on the table. I think at this point in time, if you've watched the rest of this playlist, you know how to use lever nuts and spade connectors and ring terminals to make all these connections. And if not, go back, check out those videos because we're just going to focus on the relay circuitry here. The best way to think about this whole thing is think about the relay as its own independent device that is controlled by a switch. Now, we've already talked about how to wire switches into circuits, and that's exactly what we're building on here. So power is coming from our fuse block here and is going to the relay. Power is also going to this switch here, which is controlling the relay. Think of the relay as a device that's being controlled by a switch. And the whole purpose of the relay is to control another device. So the relay is a switch that is controlled by another switch that is controlling the device. So I have it laid out here on the table. It is a little messy and confusing, and so I've made a graphic that I'm going to throw up on the TV behind me so we can see how the internal workings of both the switch and the relay work so that everything turns on and off as appropriate. So what we're looking at here is we have a 12-volt fuse block, a switch, and a relay. And on the other side, we have the switch in the other position, so the switch is off. It looks like I forgot to change the levers, but ultimately, you can use your imagination here a little bit. But we can see that this is on, this is off, so that means that this relay is on, and then over there, it's off. Now stick with me, this will make sense once we add the lights to everything. But I just wanted to paint the picture that the switch controls the relay, and that's really all it is. There's no difference here that if you substituted a light in place here, it'd have a positive and a negative attached to the relay that is controlling the internal switch inside of that relay. And here's how that looks, just sort of illustrated out. Switch opens, closes, which causes the relay to open, close. So if we introduce a load into the system, all of our negatives are tied together, and then we have our positive coming to the switch down here. That's controlling the relay just the same as before, but we also have a secondary circuit that's coming to the relay and through the relay to the light. And whenever we turn this switch on, the toggle inside goes up to connect this circuit here, circuit number 1, which closes this relay and then allows circuit number 2 to function. And here's how that looks sort of animated out. So as this goes up and down, the relay also goes up and down, which allows power to flow this way. So we have two circuits. We got the switch circuit that's coming this direction, and we have the relay circuit that's this direction. And the reason you would want to use a relay is, let's say that this circuit is pretty short. You know, let's say it's 10 feet from there to there. But from this location to your switch, you wanted it to be 100 feet away. Well, if you ran your wires from here to the switch to your load, you may have to upsize your wire, which increases costs. Because of voltage drop, you know, the wires just might have to be bigger to account for all of that. So that's why you can do a relay like this. The other option there would be if you wanted a fairly low powered toggle switch, like this one that we were messing with earlier. If you wanted a toggle switch like that to power a pretty heavy amperage load, like off-road lighting for outside, you know, a couple 100 watts, maybe like a winch, something like that, something that's a lot more high-powered that this switch couldn't quite handle. You can get a relay that's big enough to handle that increased load. So the last thing I want to talk about before we sort of wrap this video up is, what if you didn't even want to do wiring here? What if you wanted this to be a Bluetooth connection? Let's head back to the tabletop. So the hard part about relays is just all the wiring that you have to do, and you can take some of the wiring out if you use a Bluetooth relay. Now, there are some Amazon Bluetooth relays that I was actually going to buy for this video, but looking at them, they didn't have great reviews, and so I thought I would just try something a little more tried and true. The Victron Smart Battery Protect is actually realistically just a relay, and the smallest one is not that expensive at like 50-something bucks. This is a bigger one. It's 100 amps, a little more expensive. I think they go all the way up to 220 amps. So if you're just powering some light loads, which realistically 50 amps at DC, I mean, that's still a really powerful thing. You can use this to have a Bluetooth controlled relay. And here's how the wiring looks. So you've got positive and negative coming from your fuse block, positive to the in side of the Smart Battery Protect through that stud, and then out to the load there. So positive, the black wire on this particular light is positive. Negatives going negative all the way through, and then this does need a negative connection just to run the internal circuitry inside of there, but that's pretty straightforward for the most part. If this was a really heavy powering device like a winch or something along those lines, maybe like an air pump, these wires can be significantly bigger going through, because like I said, you know, this could handle 65, 100, 220 amps depending on which version you get. Now, as far as the actual operation of it, this is all the wiring you need. You don't need wiring to your switch. In fact, you don't even need a switch at all. You're just going to connect to the Victron Connect app, and then there's a load output toggle on that just bloop, and it turns on. Very slight delay, gives you a prompt, but ultimately that's all there is to it. And as long as this has Bluetooth connectivity to the Smart Battery Protect, it's going to work. Now, I don't think it's feasible to like wire every single circuit in your van up with one of these, like your water pump and your fridge and your lights and all that kind of stuff. If you wanted this kind of functionality from a phone, as well as a switch, as well as like a touch screen, you're going to want to look into the RedArc TVMS system, which will have a video coming out soon. And if the video is already out, I'll link to it down in the video description. So I hope you know everything there is to know about relays at this point, both wired and Bluetooth versions, because in the next video, we're just going to keep cruising in our branch circuit playlist, and we're going to talk about
Anderson connectors? 120 volt outlets?
Let's do Anderson connectors. Anderson connectors. We're talking about Anderson connectors next, so click up here to watch and we'll see you over there. Long way away. Hell yeah, you do, and you're going to need a relay to do it. Hell yeah, bro.
Hell yeah, bro.